Alright, so let's look at an example to see how we apply the formula. Suppose that the mean number of occurrences mu is equal to 1.2. Let's find the probability that x is equal to 2. Now, if we recall the formula for a Poisson variable, is that the probability that x is equal to xk is equal to mu to the xk power times e to the negative mu divided by xk factorial. So for this particular problem, we know that mu is 1.2 and then xk is 2, right? Because we're trying to find the probability that x is equal to 2. So then the probability that x is equal to 2 is just going to be equal to 1.2 square times e to the negative 1.2 divided by 2 factorial. Now I'm not going to work out the math here, but if you punch this into your calculator, you should get 0.2169 as your answer. Okay. So the probability that x is equal to 2 is 0.2169. Now if you remember, for the binomial variable, we had a binomial probability distribution table, right, that helps us find probabilities more easily. For the Poisson, we have something similar. So let's look at the Poisson table. So this is a part of the Poisson probability table. I have uploaded a copy of this on CourseDen, so you can always pull it off of CourseDen. So how do we use the table? The Poisson table gives probability distributions of a Poisson variable under different values of the mean number of occurrences. Okay. So what we have here is lambda. Lambda is just the way that this table denotes our mu, right? So lambda, which is just mu, which is the mean number of occurrences. Okay. So for example, when the mean number of occurrences is 0.3, then this whole column is the probability distribution of the variable x when mu is 0.3. So let's look at the problem we just did, right? So what we just did was, we know that the probability that x is equal to 2 is 0.2169, right, when mu is equal to 1.2. So how do we confirm this in the table? So when mu is equal to 1.2, you want to go to the column labeled 1.2, which is going to be this column, right? Then this is the probability distribution for our variable. Okay. Now we want to find the probability that x is equal to 2, which is going to be this row right here. And so if you trace it out, you get 0.2169 as your answer, which is exactly what we got. Now we can use this table to read the probabilities of x being equal to other values, right? For example, when mu is 1.2, the probability that x is equal to 5 is going to be equal to 0.0062. Okay. And if you want to, you can punch this into your calculator, put these numbers into the formula and do the calculation, and you should get 0.0062 as your answer. Okay. Now notice one thing. Remember that we said in the previous video that there's an unlimited number of possible values for a Poisson variable. So let's pose a question. For this table, why does the table stop at x equal to 9 even though there is an unlimited number of possible values for a Poisson? Okay. Right? Does everybody understand the question? Right? Remember in the previous video we said the number of possible values is unlimited. So we could have 50 people show up at the restaurant. We could have 1,000 people show up at the restaurant. We could have 1,000,000 people show up at the restaurant, right? So the question is, why does a table stop at 9? Okay. Now the short answer to this question, right, is that when mu is low, right? So when the mean number of occurrences is low, it becomes less and less likely to observe large number of occurrences. So for example, let's say we want to find the probability that x is equal to 10. The probability that x is equal to 10 when mu is 1.2 is going to be 0 when rounded to 4 decimal places. Okay. So for example, right, the probability that x is 10 is going to be equal to 0.0000 for mu equals 1.2 and probability rounds to 4 decimal places. Okay, and the probability that x is equal to 11 is also 0. The probability that x is equal to 20 is also 0, and so on and so forth. Okay. Now, one thing that you want to note is that probability gets smaller and smaller, but they never actually equal 0. So let me actually write that. So probabilities get smaller, but never equal exactly 0. Okay. In other words, probabilities can get to 0.00000005, but that's not 0, right? So there's a possibility that you know a large number of occurrences will happen, but it's just a very small value, right? In other words, it's so unlikely that we will consider it 0 for practical purposes. So in this video, we looked at how we apply the formula to find the probability of a particular problem, and then we looked at how we use the Poisson probability table to find probabilities.